That's very odd. It looks like this stream was deleted on Facebook. Try creating a new stream or just, that's all right. Yeah. Okay. I have a problem with Facebook. Good day, everybody, and you're most welcome to today's technical session. Today is August the 2nd, 2025. I'm Ian Cowan. Now, today we have the second of a two-part series of talks by Sankar Hajra. He spoke to us a fortnight ago on basically the collapse of the special theory of relativity. Electromagnetic fields, electric charges, and light possess momentum and energy that we can experience with our sense organs, he says, and that is evidently so. Therefore, these are real objects, entities, physical entities or objects. And therefore, all physical objects are subject to the action of gravity, and so are those entities too. And so from that, he talked about implications for the special theory of relativity last time. And this time, he's going to talk about implications for the general theory of relativity. And I think he's also, quite specifically said that it also leads to the collapse of GRT. Now, Sankar has produced a lot of information. He's published in Galilean electrodynamics and in Indian journals of physics and so on. He's written a book on linking Maxwell with Newton, and he's produced some notes relative to the talks that he's given. And I've had a brief look through these. They're quite extensive and impressive. He's done a lot of analytical work as far as I can see. And I have circulated the material at Sankar's request to our regular participants in the green room, inviting written comments, written questions. Now, I wasn't terribly sanguine about the volume of written questions coming in, in the last few days, because it does take a lot of effort and time to digest all this information. But we'd be very happy to deal with the questions orally today. And if there are subsequent written questions, Sankar has very generously agreed to reply to those. Now, we did have some difficulty last time in that, well, the language is a bit of a problem as well, although Sankar, in my humble opinion, seems totally proficient in the English language in his writings, but it's sometimes a bit difficult. And I think he's a little hard of hearing as well. So today he has another gentleman, Saman Mibya, whom I've had a few words with, who's going to assist. And I invite Saman actually to come in. If there's silence and Sankar doesn't understand something I'm saying or something another person doesn't say, please come in and speak for him. That's quite acceptable. And also, if Sankar wants to put up any visual aids, you can maybe help Saman with that, because at the moment I just have a blank screen there. But if he wants to populate that, we can arrange that. So thanks very much. Yeah, okay, we're beginning to get people in the green room. Not too many, but we have another gentleman actually. I think also from India, and he's very welcome. This gentleman we've had before. I haven't been able to speak to him. Spavieri, you may be able to come in later, but anyway, you're here. So without further ado, I'm going to bring up Sankar now. Yeah, okay. So good day, Sankar. Thank you very much for all the work you're doing for us. We're delighted to have you. And even if there might have been difficulties in digesting the material, it's available on the recording immediately after the lecture, so people can look at that. And yeah, okay, there are a lot of questions being asked here. Okay. Okay, so now, why has yeah? I think see, unfortunately, no, Roger, did you bring Brackish up there?
No, I did that mistake. there's problems with the sound again.
Okay.
Sound's playing up again.
Yeah. I'm wondering if there's an echo through Sankar's system, because he's not wearing headphones.
Yeah.
Neither am I, of course, but I've never had this problem before.
Yeah, it's feedback.
I'm getting feedback. I can hear feedback through Sankar's system. You don't have headphones, do you, Sankar?
No. স্ক্রিনটা শেয়ার দিতে বলো, না স্ক্রিনটা শেয়ার দিতে বলো, স্ক্রিনটা শেয়ার আছে, দেখতে পাচ্ছ না তো?
I can't hear that very well.
I hear them talking in the background, but the trouble is that has the echo stopped now? No, it's still there.
The echo's carrying on.
Okay. Well, we'll have to live with it, I'm afraid. We have to live with it. So I'm going to bring myself down. The problem might be mainly with my transference of voice. I'm going to bring myself down. I'm going to give the floor to Sankar, and you can start the lecture, and hopefully with every assistance from Saman there beside you.
Yes, okay? I am here.
So the floor is yours now. Yeah. So Saman, are you there? Are you there, Saman?
Yes. Can you see the screen? Collapse of relativity theory. Can you read the paper on the screen?
No. I think wait a minute. No, I think he'll have to share his screen. Do you know how to do that?
The share has been already given, but on your side, is it okay regarding sharing?
Well, all I have is that. Do you see that? It seems to be a screen which is mainly blank. Is that what he wanted to show? This screen is blank. So if he wants to put something up there, in answer to one of the comments here, I've asked whether Sankar has headphones. It's probably not possible to clear that up now. So I oh wait, is that what you wanted to put up? That's his screen. Okay. I think we're also having trouble with the Facebook access today, by the way. So, Saman, is that the homepage, Google?
No.
You got rid of it now.
Wait a minute. He's trying.
So you have to say share.
Share.
And then share what? Don't seem to have it myself. It's a little screen with a plus on it. That's the share screen. I'm sorry, ladies and gentlemen, for all this. We ought to have cleared this up 20 minutes before. That's my fault. So if you bear with us, we should have it cleared up soon. So could I give the floor to Sankar so he can start talking while you in the background are trying to put up his slides? Would that be all right,
Full screen share digital.
Salman?
The screen. It has been shared. The screen has been shared.
Okay, is that it? Right, very good. Okay.
Yeah.
Okay, so I am going to leave myself, but if you need me, just call and I'll come back. So I'm going to give Sankar the floor now.
Chapel Natural Philosophy Society Saturday session, August 2nd August 2025. Collapse of Relativity Theory. Previous talk Collapse of SRT. Today talk Collapse of GRT. Dear colleagues, I go down to my teachers, Mr. H.C. Ghosh of Bajua and Mr. D.V. Ghosh of Kolkata. I express my gratitude to the late Dr. M.C. Duffy of the University of Sunderland, who inspired me to spend my years in pursuit of understanding the foundation of the theory of relativity. I thank Dr. Ian Cowan for arranging this talk on behalf of John Chapel Natural Philosophy Society. I remember my friends and colleagues in India and especially in Calcutta. Now we shall continue our previous discussion on electrodynamics that we believe will give a new direction to our understanding of nature, physics, and relativity. In this discussion, as before, we shall only use Newton and Maxwell. We shall not use any theory of our own. In the previous discussion, we demonstrated the following Maxwell, Thomson used three space transforms and Lorentz used one-time transform to study electrodynamic phenomena classically. The three space transforms of Thomson, along with the time transform of Lorentz, are collectively called Lorentz transforms wrongly. The four auxiliary transforms should collectively be called Thomson-Lorentz transforms. More precisely, Heaviside-Thomson-Lorentz transforms, because Thomson reduced the Heaviside fields through his phase transforms. In the discussion, we shall show that the four transforms are valid only for steadily moving point charge electrodynamics, line current electrodynamics, and point charge radiations. It completely fails for steadily moving surface and volume current electrodynamics and extended charge radiation. Unfortunately, the great relativists are unaware of this situation. Auxiliary equation of classical electrodynamics. The scalar potential and the vector potential for a stationary system of charges and currents are determined by Poisson's equation, while the scalar and vector potential of a steadily moving system of charges and currents are determined by D'Alembert equation. Poisson equations are well-known tools for studying the scalar and vector potentials of the stationary system of charges and currents. However, the D'Alembert equation failed to act similarly. Thomson introduced an auxiliary system which employed a coordinate transformation trick to transform the dynamic magnetic field of a steadily moving current in electrostatic format using x dash is equal to gamma x, y dash is equal to y, z dash is equal to z, k is equal to root over 1 minus u square by c square, gamma is equal to 1 by k. U is the velocity of the system in free space. The three coordinate transforms used by Thomson may be referred to an auxiliary phase transforms. Thomson's problem was to study the magnetic field of a steadily moving system of charges and currents. He did it by transforming the D'Alembert equation into an invariant form of Poisson's. The first problem that Lorentz tackled was modeling the potential for charges moving at a constant velocity in free space. Following Thomson, he addressed this problem by transforming D'Alembert potential equation into an invariant form with Poisson's potential equation in the auxiliary system. The second problem Lorentz considered was modeling the radiation from steadily moving radiating point charge. Using Thomson auxiliary system, He solved the problem by transforming Maxwell's equation for the moving radiating point charge into the same form for the auxiliary system, which links the static and dynamic radiation state. The work of Lorentz was not complete. He succumbed to the metaphysics of Albert Einstein and followed Albert Einstein's footsteps. We present below a comprehensive study of the application of the auxiliary system in classical electrodynamics, both on charges and currents. We have shown that electrodynamics used by the relativists is nothing but the point charge line current electrodynamics and the point charge radiation in steady motion as studied by the classical physicists at the end of the 19th century. Special relativity can only explain point charge line current electrodynamics in steady motion, but not large charge, surface current, and volume current electrodynamics in that motion, which could only be treated by Maxwell's electrodynamics. Both relativists and the classicists are completely unaware of this situation. Relativity principle of Albert Einstein demands the equivalence of inertial system. When a radioactive particle steadily moves, its internal decaying process slows down, for which its lifespan increases. But if a radioactive particle is at rest on the surface of the Earth and an observer moves steadily with a justified clock in the same opposite motion, will he really measure that the lifespan of a radioactive particle has been increased? There is no such experiment that upholds that phenomena. Now I shall study
I'm sorry
everything.
to interrupt. My apologies. My apologies. But I wonder, could you slow down, please? You're speaking rather quickly, and I think a number of people are not picking everything up. So if you could slow down a bit, that would be appreciated. Thank you very much.
We have presented below a comprehensive study of point charge, line current, point charge radiation electrodynamics. Special relativity uses the same equation in their metaphysical format. We shall present two a large charge, surface current, volume current electrodynamics. The relativist equation fail there completely. This is classical electrodynamics. I have spoken this yesterday in my previous talk. All of these have been spoken earlier. But this is the Heaviside field, E field and B field. The above two equations were first deduced by Oliver Heaviside in 1888, but not by Einstein, as tacitly claimed by the relativists. The equation is the famous equation of Oliver Heaviside. The above two equations were the first deduced by Oliver Heaviside in 1888 and not by Einstein, as tacitly claimed by the relativists. Now, this is Charley's magnetic energy, equation 10. This is deduced by Charley, and then from this, the electromagnetic momentum equation P, this is equation 11, which could be directly deduced from Charley's magnetic energy. Then we come then the relation between potential, auxiliary potential, and dynamic potential, phi is equal to phi gamma phi dash. This is the relation of auxiliary potential and real potential. Thus we see that the potential phi of moving system of charges is not connected to the potential phi 0 of the same system at rest. That potential is related with the potential of the stationary system, auxiliary system, phi dash, in which all the coordinates parallel to x have been elongated with the gamma factor toward its direction of motion. These are yesterday in my previous talk, I have showed these, so I am going to other topics. Longitudinal electronic mass and the transverse electronic mass of a steadily moving point charge. The quantity is gamma cube m0, the longitudinal electronic mass, gamma m0, the transverse electronic mass of steadily moving point charge. Now this is the when a system with an independent electric field originally from charges of any shape and size and an independent magnetic field originating from the line current flowing within the system in an arbitrary direction is steadily moving with a velocity u in the OX direction, the equation is as classically deduced equation 33, 34, 33A, 34A. They are reciprocal equation. They are used by relativists. These are completely classical equation. They are. Now velocity of charge in a steadily moving conductor. Charges move in a conductor when electric and magnetic forces act on them. When the conductor moves, the electric and magnetic forces inside the conductor change, and consequently, velocity of the charges inside the conductor changes as per the following classical equation. These are all classical equations. You see, this is the velocity component dx, equation 38. Relativists claim that this equation is theirs, but this is classical equation. Dy equation 42 and 3 by equation 43. The equation 38, 42, 43 are fully classical. Relativists incorporate these three famous equations from classical electrodynamics. Transverse Doppler effect. There is a propaganda that transverse Doppler effect afford special relativity. That is not correct. As per classical electrodynamics, electric and magnetic fields inside matter change with motion, and therefore electromagnetic process inside the matter should change with it. Slow. The radiating dipole at rest, force acting inside it is elastic force F0. When it moves as per Heaviside, the force acting inside it is F0 root over 1 minus c square by c square as per Heaviside. A dipole radiates when an elastic electromagnetic force acts inside it. When the dipole moves transversely, the fields change inside it and a B field is induced inside it. Both the force decrease the force inside the dipole by k factor, and consequently frequency and time period of the oscillation of moving dipole change as per the following classical equation. That is, frequency changes as per this equation omega equal to omega 0 root over 1 minus c square by c square. Naturally, time now the frequency changes, time period changes. T is equal to gamma T0. Time period also changes. This is not time dilation. This is oscillation, increase of oscillation of time period. Increment of lifespan of moving radioactive particle. There is a part propaganda. The lifespan increment of radioactive particle in motion pulsation. That is not correct. Electromagnetic forces inside the moving system decrease by k factor, and hence the lifespan increases by gamma factor. A radioactive particle decays when electric and magnetic forces inside the particle act to disintegrate the particle. When the radioactive particle moves, the electric and magnetic forces acting inside the particle change, and consequently, the disintegration process in the moving radioactive particle change as per the following classical equation. This is the decay equation when the particle is at rest. N0 e to the power minus lambda f0 t0 force. This is there is a force, and this is when the moves, the force changes inside the particle, and as the force changes, time period and comparing equation 51 52, we get t is equal to gamma t0. That is as the decaying process decreases, and hence the time period increases. That is, lifespan of a particle increases with velocity. This analysis at once destroys here is one time, there is another time concept, as well as the twin paradox of relativity. This is third derivation of Lorentz transformation equation. It is a classically derived Lorentz transformation equation, but here the equation is auxiliary, real, not real. This is famous auxiliary equation, equation 59. It has been derived from Thomson's auxiliary equations and Maxwell's equation. It has been derived classically. It should be mentioned here that the quantity x dash, y dash, z dash, t dash, e dash, b dash, z are auxiliary. Thus, from the standpoint of electrodynamics, Lorentz transformation equations are tactical, just like the tactical equation of Thomson. These auxiliary equations are very useful to solve correctly the electrodynamic and radiation problem associated with steadily moving electromagnetic bodies classically. Under no circumstances the equations are real. To consider all four Lorentz transformation equations as real is an oversimplification of electrodynamics and nature. Now, velocity of light in dielectric.
Velocity of light in a dielectric steadily moving in free space.
Fresnel drag coefficient in Thiau experiment. This is then we get this formula Thiau drag coefficient. Fresnel drag coefficient is derived from this velocity addition equation. This is classical. is now primarily electromagnetic phenomena. Electromagnetic fields possess momentum energy that we experience through our sense organs. Therefore, electromagnetic fields are real physical entity objects. All objects are subject to the action of gravity. They are carried with the earth at the near vicinity of its surface and experience Coriolis force when they are part of the earth system and move with respect to that system. All electromagnetic entities act similarly. This will immediately explain the now result of the Tautomobile experiment, where there is no magnetic field near a stationary condenser on the surface of the moving earth, and two, the now result of the Michelson-Morley and similar experiments in water, in air, the now result of Michelson experiment using the light, sunlight, or the starlight, because the earth carries electromagnetic fields along with it. This explains why early observation of the aberration of stars through a water-filled telescope is the same as Barley observation through an air-filled telescope, and why light beams coming from the tops of mountains show no aberration. All of these confirm that the earth carries electromagnetic fields along with it. When a light beam electromagnetic vibration moves across the earth's surface, that vibration is carried along with the earth. And just like all other physical moving objects, it experiences a Coriolis force acting on it. Therefore, a clockwise rotating beam in northern hemisphere will be pulled inward towards the center of the circle, and an anti-clockwise rotating beam in the same hemisphere will be deflected outward from the center of the circle. This causes a phase shift in the rotating beam as shown in Michelson-Gale experiment assisted by Pearson. We have also explained rationally the straightforwardly the time gain, time loss hepatic experiment. Why are the laws of reflection, detection, and interference of astral light and sunlight the same as those of the terrestrial light? More specifically, why does the Earth's surface behave like free space? There is only one answer. The Earth carries electronic field along with it. When the Earth translates, rotates, or spins, electromagnetic fields also, along with it, also translate, rotate, and spin. Contrast looks. No phantom physics is required to explain such phenomena. All electrodynamic phenomena like reflection, refraction, diffraction, interference, etc., as observed on the surface of the earth, either with starlight, or with earthlight, or with sunlight, are independent of the movement of this planet. That is, the earth's surface is exactly equivalent to free space for our description of the electromagnetic phenomena on it. Now, these have been told in the previous talk, however the Tautomobile experiment it is. In a laboratory, when a charged condenser moves, the electric field around it changes, and thereby a magnetic field is created around the condenser. If the electric field originating from the condenser were to move along with the condenser, there will be no change in the electric field around the condenser, and thereby there will be no magnetic field around it. Now, a condenser at rest on the Earth's surface moves with Earth, but the electric field around the condenser too move with it, and therefore there should be no magnetic field around the condenser when it is stationary on the surface of the Earth, which is moving with high velocity in free space. Therefore, the Tautomobile experiment fails to detect any magnetic field around the condenser. This implies Earth carries condenser along with the electric field. This is microscopic experiment. Earth translates along with air, water, electromagnetic fields at the vicinity of the surface. Therefore, the motion of the Earth should have no effect on the velocity of light in air or water when measured on the surface of the Earth. This is at once explained the now result of all the Michelson type experiments in air and the Muscat jamming type experiment in water at rest on Earth's surface, and may give us some insight to understand why all electromagnetic phenomena as observed on the surface of the Earth are independent of the motion of this planet. Now, it is Sagnac experiment. It proves that relativity is not correct. Sagnac effect on spinning this proves by direct tangible experiment the light speed is relative, not absolute. Now, this is Michelson-Gale experiment. This beam is clockwise rotating, and it is going inward towards the center of the circle, and this beam is going anti-clockwise, and it is going outward to the circle, and hence the phase shift. And this is the phase equation 62. This has been calculated. Now the halogenating experiment. In a long paper, I have shown that this experiment, time gain and time loss, can easily be calculated from classical physics. Now, Bernoulli observation, you see, the first picture represents Bernoulli's. This is Bernoulli observation. The star ray is coming by this real star, but due to the motion of the Earth, the apparent direction is this, and when it is come to the surface of the Earth, it is a part of the Earth. That is when there is air, the same aberration, and when there is water with the same aberration. And if it is mountain top, there is no aberration. It is very clear. The light is coming from the stars, and Earth is moving toward a direction. Apparent direction, this is there is air in Bernoulli experiment, there is water in experiment. When it moves, when the ray comes in the surroundings of the Earth, it will be carried with the Earth. Therefore, there will be no further aberration, as you observed by IRE. Same aberration as shown by Bradley. And there is no aberration if a ray comes from the mountain top, as the Earth carries the mountain top as well as the electronic field along with it.
Important below, you go more slowly, which is
And
important.
now I coming to the large charge electrodynamics. It is a very long chapter. However, I am showing that large charge electrodynamics and point charge electrodynamics are totally different. You see, this I have calculated here. It is not possible here to show all the mathematical calculation. This is for point charge electrodynamics. These equations are valid for magnetic and electric field transformation. This is from classical mechanics, classical electrodynamics. But for large charge electrodynamics, that will fail. All the calculation will be different. All the calculation will be different. With all these, the transformation equation are different, field equation are different, and magnetic field equation are also different. Both electrodynamic calculation based on Maxwell equation and relativistic calculation from Einstein are identical for electrodynamics for point charges, line currents, and point charge radiation. However, the results of the two different calculation methods differ significantly when a moving charge body on the moving charge body or the moving charge itself occupies.
Please repeat this one. However,
However, the result of the two, however, the results of the two different calculation methods differ significantly when a moving charge body or a moving charge itself occupies a substantial volume or surface. The most remarkable difference arises in the calculation of the effects of electromagnetic system stationary on Earth, while the observer measuring the effect moves relative to it. All meticulous experiments to establish relativity in the domain of electrodynamics are related somehow to point charge electrodynamics and radiation problems of dipoles. In cases when electromagnetic systems move steadily and the stationary observer measures the effect, relatives cite the results of these experiments in their favor. However, the same results could also be predicted from Maxwell in those cases. Without experiments on large charge electrodynamics and on the effects of stationary electromagnetic system on Earth observed by a steadily moving observer, special relativity could not claim its superiority over Maxwell electrodynamics. Unfortunately, relativists are innocently unaware of the crucial situation. The goal of our presentation is to demonstrate that auxiliary Heaviside Thomson-Lorentz transformation are unique classical tools for studying electrodynamic phenomena of steadily moving point charges. But these equations could in no way explain the null result of the microscopic experiment. To explain the null result, Albert Einstein assumed that Lorentz transforms are real, and this is known as equation theory relativity. According to this theory, bodies contract with motion and time dilates therein, and Heaviside-Thomson-Lorentz equation hold not only for point charge electrodynamics, but also to large charge and even to the material world, and a phenomena that gives rise to a phantom world. In that case, the said experiment will yield null result. On the other hand, we have presented evidence that all electromagnetic fields are real and hence subject to gravitational forces. In that case, the electromagnetic field will be carried by the Earth. When the Earth translates, rotates, and spins, this field will similarly translate, rotate, and spin with it, experiencing the Coriolis force when the field vibration moves with respect to the Earth's surface. This will immediately explain the null result of the microscopic experiment and the non-large result of the microscopic experiment assisted by Pearson. This will provide insight into why the surface of our planet is exactly equivalent to field space. This world we think is real, not a phantom. What do you think, colleagues? I am now going to my second portion, collapse GRT.
Are you finished already, or do you wish to
I'm going
continue?
to the second part. Collapse of
You're
GRT.
going to start the second part now, are you? Yeah. Sam, I'm a little confused. Is that the end of the formal talk? Because he has another half hour if he wishes.
half an hour.
Half an hour.
It a second one.
Second one. This is second one.
Second one. Try to.
Okay, we give you another half hour.
Would you kindly share? Yeah. Screen share.
No, I don't have anything that you wish to share. Have you put anything up?
He is trying to fix the second paper.
Okay, take your time.
Collapse of GRT.
This is collapse of GRT. Huh?
You just click the screen with the plus sign, and then ask to share, preferably your screen. That should work.
From here the screen share is given.
Okay.
Now
you have to press screen share again.
Oh.
Once you've done it, say share, because I don't have anything as yet.
Oh.
You've given extensive material, which I have had the opportunity of having a look at. And in fact, people have been asking for PDF documents. Now, I've taken the liberty of giving them a link to your book. I hope that's all right. I did refrain from doing that originally for copyright reasons, but you were presenting it to me and you asked me to present it to our regular contributors, which I did, as you know. But I've also given a link now to people because they need material background. I think they're sort of asking maybe if you could concentrate now on how it relates to GRT, how it falsifies GRT, how it falsifies the whole concept of a space-time curvature. So let's see, have you got anything up yet? No, I don't see anything yet, gentlemen. Yeah, I have another. I think it's maybe it might even be your son. I don't know. Saying what I said. If you don't mind me saying, you're speaking far too quickly. If you speak much more slowly, people will be able to gather it because it's new to most people. You must realize.
Accent. So, you have different accents, so you need to you need to spell with a gap slowly.
Wait, I have it now. Is that it? Okay. I'm going to leave it to you now. You have 20 minutes
Oh,
if you wish.
20 minutes
So,
back.
so
Yeah,
go
thank you.
ahead.
Collapse of GRT. In the present discussion, we show that electric charges possess. In the present discussion, we show that electric charges possess momentum and energy that we can experience with our sense organ. Therefore, electric charges are two real physical entities. All objects are subject to gravitation. Electric charges too are subject to gravitation. Just like electromagnetic fields, they will be carried with the earth and they will experience the correlation force when they move with respect to the surface of this planet. We shall show below that this simple consideration is equivalent to GRT. To reach such an interesting conclusion, let us review three electromagnetic quantities: electromagnetic momentum, longitudinal electromagnetic mass LEM, and transverse electromagnetic mass TEM, relating to a steadily moving point charge. Three classical electromagnetic equations. Following Maxwell Heaviside, Charlie elegantly deduced the magnetic energy of a steadily moving point charge. Following Charlie, we have deduced the electromagnetic momentum P, longitudinal electromagnetic mass LEM, and transverse electromagnetic mass TEM classically, which are follows: 73 electronic momentum, 74 longitudinal electronic mass, 75 transverse electronic mass. Now the question arises, if a point electric charge is subject to gravitation, what should be the contribution of the real electromagnetic masses to the gravitational mass of that charge when that charge steadily moves in a gravitating field? Now the question arises, if a point electric charge is subject to gravitation, what should be the contributions of the real electromagnetic masses to the gravitating mass of that charge when that charge steadily moves in a gravitating field? The, the, the equation of motion of a point charge in an electronic field is determined by those two real electromagnetic masses, that is, longitudinal and transverse electromagnetic masses of a steadily moving point charge. Therefore, when a point charge interacts with an electronic field, the direction of acceleration and the magnitude of acceleration of the interacting charge is different for different direction of movement of the point charge in that field. In case of a point charge is subject to gravitation and it has diverse direction of motion in the same gravitational field, the magnitude of acceleration of that point charge should be same as that of a point charge in the same gravitating field, and the direction of acceleration of the charge should be same as the direction of the gravitating field all the time. Transverse electromagnetic mass should have no role in that interaction. If transverse electromagnetic mass would have any role in gravitational interaction, neutral material bodies having charges inside should have acceleration, not always directed towards the center of gravity of the gravitating body. And that acceleration too would differ in magnitude when those bodies would move in different directions in the gravitating field, which are not observed by any precise experiment. This implies that the gravitating mass of a point charge is proportional only to its longitudinal electronic mass, gamma cube m0. Transverse electromagnetic mass has no role in the interaction. Now let us consider a material body having a material mass mm containing q amount of positive and negative charges with the raised electromagnetic mass m0 in total inside. And for simple calculation, assume that the positive and negative charges are concentrated at two different points separately near the center of the mass of the object. Therefore, a neutral body at rest in free space should be composite of two masses, mm, material mass, and m0, the electromagnetic mass, is equal to lem m0. Here, mm is the invariable material mass and m0 is the invariable electronic mass of the charges inside the body at rest in free space, both of which are subject to gravitation. Now, m0 may be called the total gravitating rest mass of the body, containing charges inside, that we measure in the laboratory. But neither the material mass mm nor the rest electromagnetic mass m0 associated with the body is known to us. We know only the total gravitating mass lem m0 of the body at rest, which is measurable quantity measured in the laboratory when the object is at rest in the laboratory. When the velocity of that body containing charges is large, Gravitating mass of the body should change to mm plus gamma q n0 as per our previous discussion, which we could not determine anyway. Therefore, this value of that mass of a moving body containing charges could not be used for experimental physics. However, it is obvious that the quantity could not be greater than gamma cube mm plus m0 from gamma cube lame m0, which is a determinable quantity, and therefore we could use it as a limiting maximum gravitating mass of a neutral body having charges inside, moving with high velocity to study the motion of the body containing charges in a high gravitating field. Thus we see that the limiting gravitating mass of such a body LGM is equal to gamma cube lame m0. If Galileo's experiment was exactly valid for neutral bodies, this mass is proportional to the inertial mass of the body. That is, LIM should be also will be gamma cube lame m0. Therefore, therefore mechanical momentum of the body should be gamma cube lame m0 u, exact equation of planets around the sun. If we use this equation, we could easily explain the advance of perihelion Mercury. The
Precision.
Let us now study the motion of a planet which obviously contains charges with an initial velocity u having the limiting mass gamma cube lame m0. When it passes through the gravitating mass field of the sun having mass m, material mass plus mass originating from the associated charges, the subsequent motion of the planet will be confined to the plane containing the direction of acting force and the direction of initial velocity. Let us fix a polar coordinate in the plane where the center of the sun is the origin and the initial position of the planet is equal to r theta. Now the radial force acting will be equation 80. This is the sun's mass is m and the planet's mass is gamma cube m0. And equation 1 will be cos radial force 1 by r dt gamma cube lame m0 1 to r square d theta by dt is equal to 0. And this is the angular momentum equation 82. If we combine these three equations, 81, 80, 81 and 82, we will get this equation. d2u by d theta 2 plus u is equal to gm by h square plus 3 gm by c square plus square. The equation 92 explains the advance of perihelion on Mercury. And if we consider that the light is also subject to gravitation, then this equation will be reduced to 92 will be reduced to equation for 91, which will explain the bending of light rays reaching the surface of the sun. Now, gravitational redshift. Similarly, a ray coming from the distant star will lose its velocity due to the gravitational force of the stars acting on the ray, and thereby the frequency of the ray will change as it moves away from the star. The average reduction is given below. The rays coming from the surface of the stars, here the frequency of the ray omega s, and when it will come to the surface of the earth, the sequence will be changed to omega e. Let apart the gravitational acceleration of the ray on the surface of the star, and affects the gravitational acceleration of the same ray when it on the surface of the earth. From law of gravitation, Fx by Fr, r square by x square, and Fx equal to gm by x square. Using this equation, we get this equation: velocity of light at the surface of the earth Ce, and velocity of light at the surface of the star Cs, and We by Cs equal to 1 by gm by rc square. This is same as gravitational redshift. Precision of gyroscope. We have shown before the limiting inertial mass of a neural material body having charge inside, limiting inertial mass is equal to gamma cube lame m0. Then suppose a gyroscope, this is a gyroscope, is rotating around the earth, and this is the second position. This is now this direction OP is the constant direction, the direction of the earth move, but the any infinitesimal mass element of this gyroscope will not the same direction. This direction is OP, but when it moves due to our new momentum equation, it will be shift towards OP1, and there will be angle, and it will create a torque on the body of the gyroscope, and it will create the gyroscope to precede. This gyroscope is moving around the Earth. Now, OP is the direction of movement. It is a constant direction. The center is moving towards OP. But any body element of this gyroscope will not move in this direction due to a momentum equation. It will be shifted towards this. The direction will be shifted. And for this, a torque, there will be a torque on the body of the gyroscope, and the gyroscope will be preceded. It is simply a classical consideration. In that case, three gyroscopes rotating in the Earth's orbit should demonstrate some interesting phenomena. In the orbital motion, the center of the gyroscope will move in a particular constant direction OP, but every infinitesimal mass element of the gyroscope will not follow the same direction. Following the momentum equation, in this momentum equation, the gyroscope will depend. We have calculated this precision, and we have seen that this is same. The result will be the precision will be d theta by dt is equal to omega g over square 32 u square by c square omega g, where omega g is the angular velocity of the gyroscope in its orbit, which has been demonstrated in gravity proof B experiment. This is orbital precision, or called de Sitter precision. This precision can easily be explained from classical physics, considering that electromagnetic momentum of a gyroscope, electronic momentum in a gyroscope, is defined by this equation 79. That is equation 79. This equation, P, equation of momentum. If this is gamma q lim m0 u, this is the momentum of the gyroscope. Then the gyroscope will be precede. This is orbital precision. Similarly, the orbital precision. Similarly, you can easily deduce orbital precision of Thomas precision. Here also same. The result will be minus 1 to u square by c square omega e, where the angular. This is the omega is the angular velocity of the electron in its orbit, and equatorial precision orbiting the spinning gyroscope, length-string precision. Similarly, when a gyroscope rotates in its orbital plane, a Coriolis force acts on the body of the gyroscope. This Coriolis force will modify motion of the center of the gyroscope in its constrained direction, but every infinitesimal mass element of the gyroscope will not follow the same direction. Following the momentum equation, this 79. When direction, motion of center, and the direction of motion of the body elements of the gyroscope, which will force the gyroscope to proceed in the tangential plane of the Earth at the observed point. This effect is completely classical and may be called Coriolis precision, as observed by NASA gravity probe B. This is Coriolis precision. চলবে না এই হচ্ছে চলছে তোমার এখানে চলছে চলছে না no the video is not working yes the animation animation are you seeing
I'm not certain, gentlemen, if that's the end or if you want to go on a little more. You have 5 more minutes if you wish.
5 minutes to me.
Matching the 15th century.
Okay, I'll let you
In
go.
the last part of the 20th century, American scientist H.G. Taylor, in the lecture Binary Pulsar and Relativity Cavity, showed that the calculated gravitational radiation loss of binary pulsar PSR 1913/16 matches well with the constant contraction of the orbit of the pulsar from which he claimed the existence of gravitational wave indirectly. However, Eller et al., some experts on the central relativity maintain that the problem of motion and radiation in the general relativity theory of holds. Pulsar electromagnetic bodies, orbits of electromagnetic bodies should not be stable from the electromagnetic viewpoint. Therefore, the pulsar is not ideal object to study the radiation of orbital decay with esoteric gravitational radiation. Direct detection. Recently, Ligo and Vargo have claimed that they have adequately detected gravitational waves by using Michelson interferometer. Scientists believe that gravitational waves cause space itself to stretch in one direction and simultaneously compress in perpendicular direction. This causes one arm of the Michelson interferometer to get longer while the other gets shorter, and then vice versa, back and forth along the wave passing. As the length of the arms change during propagation of the gravitational wave, so too do the distances traveled by the laser beam. A beam in the shorter arm will return to the beam splitter before a beam in a longer arm. Then the situation reverses. Over time, the arms oscillate between being longer and being shorter, arriving at different times. The waves of light no longer meet up nicely when recombined at the beam splitter. Instead, they shift in and out alignment of the phase as they merge while the wave is causing their length. So when gravitational wave passes through a Michelson interferometer, a detector will register the phase shift that should be measured the strength of the passing gravitational wave. The LIGO Virgo scientists assume that the speed of light in both the space that is steadily stretching and the space that is steadily compressing are the same, c as that of light in free space. Could this be correct? According to Maxwell, the speed of light inside a normal dielectric v is equal to 1 by root over e into mu, E being the permittivity and mu the permeability of the dielectric. Now, if the length of the dielectric is stretched by factor A, then the speed will also change inside it. Similarly, the speed of light in free space, c, 1 by root over E0 by mu 0, being where E0 and but when it is, if that space is stretched by factor A, then the speed of light in the stretched space is c dash, will be c dash, root over 1 minus E0 dash and E0 dash. And in that case, stretching will change the velocity of light in that space. Therefore, the speed of light could be the same in both in steadily stretching dielectric and the steadily compressing dielectric. The same is the case for light beams when they move in the free space and the distorted phases. In the given experiment, light will not always traverse a given distance at the same time if the space is alternating between stretching and compressing. The present analysis contradicts LIGO-Virgo perception of the experiment and attacks the theoretical foundation of the detecting process. To justify the theoretical foundation of the LIGO-Virgo experiment, LIGO-Virgo expert should prove with an independent experiment that the speed of light is really the same c in the steadily stretching and steadily compressing spaces, just like in a free space. They have not done this yet. Therefore, LIGO-Virgo detection of GWD effect, Einstein's gravitational wave is the outcome of his phantom physics. Chancellors of the big universities are the patrons. $1 billion industry for a detection is the primary propellant. Video দেখাও just Hello, may I show a video?
For how many minutes?
3 or 4 minutes.
4 minutes.
1 to 2 minutes.
Maximum 1 minute.
1 minute.
Maximum.
জিজ্ঞেস করতে বলো শুনতে পাচ্ছি
শুনতে পাচ্ছ
এটা তো হ্যাঁ তুই বলো কথা শুনবো
কানেকশন অফ হয়ে গেছে
দেখানো খুব মুশকিল হয়ে গেছে
কানেকশন হ্যাঁ এবার ইটস ওকে
কথা বলেছে
না বল
Okay, may I show a video for 1 minute?
No. It is not possible to show. So you cannot feed the system. You cannot feed the video in the system.
Oh,
So there is a.
তাই করো।
So
হ্যালো, আমি দেখালাম তো হয়ে গেল শেষ।
ওদের
লাস্টে
connection
কি
off
শুনতে পাইনি?
connection off হয়ে গেছে।
You wanted to show a video, did you?
আচ্ছা,
I can try.
চেষ্টা করছি।
I've put in the comments a reference to Sankar's book linking Maxwell with Einstein. It's available on Kindle. I've checked it myself, although I think some people are having difficulty locating it. I gave the ISBN in case anybody's interested.
ISBN. Have you given the ISBN of your book? He
Yes.
wants to place. He wants to show the ISBN number of your book. Have you?
Yes, I have given it.
Yeah. So he's kind enough to.
No, I've done that already. It's ISBN 9789334199741. Okay, wait a minute. I have something now here.
আচ্ছা, বলো শেয়ার করতে।
I'm
So
going away
would
now.
you please share if we can show some video?
Well, you'll have to put your video up on the screen. Now, you've already shared it, so that should be possible. If it's not a terribly long video, that is.
No, very short.
Very short.
Short, okay.
Very short.
There are not many private
Now,
chats coming in.
did you get?
Oh, I agree with his conclusions about phantom physics. Yeah, okay. We haven't had many private comments, but we have had quite a number of public comments, although mostly are just conversations between each other. Okay, I'm going away now.
Oh, no, off. দুটো তো
ভালো আছে, ভালো আছে, একটু আরেকটু আমি বলে দিচ্ছিলাম, আমি দেখতে পাচ্ছি।
ভালো দেখতে পাচ্ছি।
একটু
Okay, our video is finished.
প্রশ্ন জিজ্ঞেস করবে।
Does that mean that you've completed your talk today? Are you finished?
Yes.
Okay, well, we'll start the discussion then. So thank you very much. Perhaps I'll just come in first. Well, thank you so much for all the details you've given us. I feel at a slight advantage, actually, in comparison with most of our participants. unfortunately, because I've had the opportunity of looking at the material. It's quite copious and detailed, and I really think people ought to buy your book. I think it's something like 600 Indian rupees, which is only a few dollars, and you can get a Kindle version of it as well. There are some other papers which I think some people have actually got to now in the references. For example, you've published in the Bulgarian Journal of Physics. But as far as I can see, it's very, very detailed information, very analytical, and you've gotten to the basic equations. Now, so I think what we might do is, well, maybe just a comment or two to start things off. In my communication with Sankar, I did say that I didn't really conceive of there coming in a lot of written requests, to talk about your paper and so on. I think people will be more interested in raising questions orally. Now, I have had a quick look at the paper, and we had commented already on the question. Yeah, okay. I'm just reading some of the questions coming in. Pardon me. And I told him that I might have one or two questions on his equations or aberrations, so on. So maybe I'll start with one general question, which relates to the analytical model, because as far as I can see, you deduced an equation, for the orbital principles, based, I suppose, on Newtonian physics, but with an additional term, which is basically the same as the term derived in GRT, which in turn is the same as that derived earlier by Gerber. He was assuming a finite speed of gravitational interaction, and you I think got this term assuming that mass isn't the totality of things to be put into that equation, but you need a sort of a charge which is analogous to electrostatic charge. I think you talked about transverse mass disappearing, but you're having this charge. So you brought in a gamma cubed, or maybe gamma to the power of 6 factor, which gives the same equation, as far as I can see, if I'm not wrong, as Einstein does or Gerber does for the excess planetary precession of Mercury over that accounted for by looking at the interaction of forces from other planets and so on. Now, this 43 arc seconds was a big thing, I mean, for over 100 years, and people were trying to figure out an equation to account for that. But on the other hand, there are some problems I might put in. I might say that, as you yourself pointed out, Sankar, there's a total precession of over 5,000 arc seconds as viewed from the Earth, due to the influences of other planets. Now, I think if you do the calculation in absolute space, what I call absolute space, you'll get something like 5,000 arc seconds. So this 43 is a very, very small amount, which might be very difficult to account for exactly by experiment. And on the other hand, I think it has been revised. I think 43 isn't the magic figure that the mainstream would accept nowadays. It might be much higher. So I suppose what I'm saying in a long-winded way is that it's interesting that you get this value. It comes out of your equation, but maybe that isn't so impressive, because Einstein got the same and Gerber got the same, and it's a bit of a perhaps curve-fitting endeavor for something that might be not very consequential. Now, I don't know if I've been very clear, but would you like to say a word or two on that before we address the questions?
বললো তোমার ক্যালকুলেশনটা কি 5000 ফিগার আছে 5000 কোন একটা ফিগার হ্যাঁ
কোথায়
I mean, perhaps I've been very long-winded myself, and it might be that you're getting this expression for planetary precession is the same as GRTs. Now, personally, I'm not impressed by the GRT equation, which is meant to be one of the proofs of GRT. But I could say that I'm not terribly impressed with yours as well. You're getting the same value in another way, or Gerber's. But anyway, we can come back to the discussion. Let's have a look at the.
No.
He
doesn't know
there are a couple of questions you might like to address. So if you give me a second just to go through them, I'll put them up. Okay.
Garbar.
Okay. Okay. I'm only going to pick out a few questions because we don't really have time. So we'll concentrate maybe on something which is the most accurate. People are raising things about weak force and so on. Well, Robert K has asked, I'm not quite sure what he's getting at, but he said, if we conclude that the Sagnac experiment is incorrect, why are we concluding that the LIGO interferometry is correct?
Sagnac is the incorrect thought. If Sagnac is incorrect, why LIGO is correct? He is asking.
Sagnac measured the velocity of light in a rotating disk. He and his followers first put the interferometer and the light source in the rotating disk on the platform of the table, but always he got the velocity of light is changing. That Sagnac effect directly proves that the special relativity second principle is incorrect. But relativists shaped the proposition by using the it is a rotating disk. As it is a rotating disk, so you cannot say that the experiment is valid for the translatory motion. This is the expansion of the relativist, but I believe the relativist expansion is not correct. Sagnac effect directly proves that the velocity of light is not absolute, is not correct.
Yeah, I think he appreciates that. So, in my humble exposition of what you were saying, I think it was that the Sagnac experiment is correct, and it shows a variation in the speed of light. But the LIGO interferometry is taking a constant speed of light, even though the space is perhaps stretching or compressing, ostensibly. So I think it's the other way around. I think you were saying the Sagnac experiment is correct, but the LIGO interferometry exposition is incorrect. So anyway, that's my understanding of what you were saying. Contradict me if it's wrong.
He is saying that you understand that Sagnac is correct and LIGO is not correct. Is it true? You understand that Sagnac is correct and LIGO is not correct. Is it true?
I believe that Sagnac Sagnac experiment has been repeated in translatory motion by R. Wang. R. Wang also believed that the velocity of light is relative. Sagnac experiment has also been repeated in a translatory motion. That is why R. Wang has done this in 2003. Therefore, I believe that Sagnac experiment directly proves that velocity of light is relative. It is not absolute. I believe this.
Okay, yeah. So that seems not terribly far from what I was saying. Okay. Okay. We'll come to the green room now in a moment, because I want to get some of my learned colleagues' views. Well, here's a very quick thing from Robert K. He says, "Is Sankar arguing for an ether?
No,
Do
I
you
am not
support
arguing
the
for
concept of an
ether.
ether?"
I am not arguing for ether because why are why ether will clung to the earth? That cannot clung to the earth. Electromagnetic field is more realistic vision for electromagnetic explanation, electromagnetic phenomenon explanation. Ether, yes, ether is a fundamental concept. Ether is a good concept, I believe. But electromagnetic field conception is better. If we replace ether by electromagnetic field, electromagnetic field is real physical entities. Therefore, if we use ether, if we use electronic field instead of ether, that will be better explanation for electrodynamic equations, electrodynamic phenomena. Ether is good, but electromagnetic field conception is better.
Okay. Well, this is a more of the nature of discussion. Robert K says GRT predicts. We know these are the claims: black holes, space is curved near large mass, light bends in large gravitational fields, the perihelion of Mercury shift, gravitational redshift, gravitational waves, and fluctuations. And then he says, where is the collapse in all this? Well, it appears that Sankar is arguing for some of these experimental elements from another way. In other words, through classical physics. And some of the other things are debated. So I would strongly advise Robert K to have a look at his book. It's well worth studying. It's got some advanced mathematics in it. You have to concentrate on it. But I'd have a look at that to see what his argument is. I think it's not easy, maybe, in the discussion
Robert
to
K
prove his point, unless you want to add anything to it, Sankar. Okay. There's the ISBN for his book, by the way.
Robert K has asked me, why am I contradicting really GRT? Yes, I am contradicting GRT because I do not believe in space-time curvature. Albert Einstein has assumed a space-time curvature. I do not believe in a space-time curvature. My world is Newtonian world. It is totally different from Einstein's world. So I do not believe in Einstein. I do not believe in Einstein. He has assume a space-time curvature of the space, but I do not believe in this concept. I believe in Newton's space and time. Robert K has asked me why that I am not do I believe in space-time curvature? No, I do not believe in space-time curvature. All the phenomena that are explained by relativity, by gravitational effect, by the relativistic gravitational effect, I don't believe in those facts. I can explain all those phenomena through Newton and Maxwell, everything. Nothing. I shall go beyond this. I shall not go beyond this. I can explain all electrodynamic and gravitational phenomena through Albert Einstein, through Newton and Maxwell. No need of Albert Einstein in my expression. Everything, every phenomena, every inch of this, every phenomena of the world can be explained from Newton and Maxwell.
So I think this had better be the last question before we go to the green room. He's asking, does Sankar think Michelson-Morley can never get non-none results, or is it possible, and why? So you were talking about frame dragging and things like Coriolis forces and so on.
My ether Earth is carrying electromagnetic field with it. Therefore, there will be always null result in Michelson-Morley experiment. The Earth is carrying electromagnetic field along with it. Therefore, Michelson-Morley experiment will always register a null result. This is purely classical. This is now the result is purely classical. The Earth is carrying electromagnetic field with it. Therefore, velocity of light will be the same on the surface of the Earth. Just like Earth is carrying light, carrying water, air, etc., that is also carrying the electromagnetic field with it. Therefore, there will be null result in the Michelson experiment. It is easy and simple. No need of any theory. No need of any theory.
Right. Well, if we could now maybe entertain a little discussion from people in the green room. If there are any hands, just signaling. This gentleman, whom I don't think we've spoken to directly, Gianfranco Spavieri, he's written a number of interesting points in the green room. Basically, as far as I can see, supporting Sankar and enjoining us to consider his material in detail, which I concur with. I mean, people should really get his book. And he asked a question. We had commented already on this about the question of interpretation of the text of gravitational waves. Yes, and he says, what would be the result of the Sagnac experiment performed in empty space in the absence of gravitational fields or with uniform fields? But I tried to bring you up once before, Mr. Spavieri, but you didn't respond. Can you hear me now? You're up. Can you speak? You're mute. Have you any microphone access? No, he doesn't seem to respond. I don't know why. You're not responding, Mr. Spavieri. So, and your private chats, I can't actually put them up on the screen.
Now he will respond. Now
We have to leave that for the moment. He might come in now. Gentlemen, anybody else? We have Vladimir, we have James, and we have Denny here. Denny, good, yeah. So, Denny, I'd like you to give your response briefly to this and maybe ask any questions, please.
Well, as I see it, the big problem with gravity and curious about it is that it can include electromagnetism properly. A man by the name of Morton F. Spears has published in 2010 in the Galilean Electrodynamics an electrostatic solution for the gravity force and the value of G, which is Newton's constant. And it's volume 21, number 2, 2010. And this article was published posthumously. He had died when the article was submitted. His daughter submitted it for him. He got together all his notes and whatnot and published it for him. And so I finished it up by publishing a book on Kindle Publishing, which finished up his theory and linked it with earthquake early warning. And this allows one to realize that the reason why Newton's gravitational constant, capital G, can be computed correctly, experimentally, to more than 4 or 5 digits accuracy is because instead of 8 or 10 digits as they would like, is that there's a hidden variable, the electrostatic variable with its permittivity or dielectric constant. And so that explains why Newton's gravitational constant has not been successfully computed to more than 4 or 5 digits accuracy. Some people have computed it to more than those digits. Their numbers don't agree to more than 4 or 5 digits. And that's because of a missing variable, the permittivity of the surrounding matter when the experiment is being performed to calculate G experimentally. And the other thing I'd like to bring up is that a Russian whose name I cannot recall, but he is into computers. He's located in Siberia somewhere, which is a huge landmass. I wish I could be more specific. But he has calculated that since the sun rotates it can't be considered to be a perfect sphere. It's narrow at the poles and bulges at the equator. And as a result, if you take that into account, you get the right answer for the events of perihelion of Mercury by doing that particular corrections with the usual calculation. And so the event of perihelion is predicted then by Newton's law of gravitation without any help from special general relativity or even special relativity. And so just the sun rotating and hence bulging a little bit at the equator and narrowing a little bit at the poles.
Yeah. This business of the oblate spheroid, and there are other effects actually which could affect the precession. Things like the rotation of the center of the sun at a greater rate than its periphery, things like that. It's such a small value that we seem to be making a meal of it. 43 arc seconds.
Well, the thing was that Einstein built his reputation on the fact that there was an eclipse of the sun by some famous English physicist, whose name I can't.
Eddington.
And
Sir Arthur Eddington.
Huh?
Sir Arthur Eddington.
Yeah, Eddington. That's right. Yeah, and when people have looked over his notes, now that he's passed on, and he looked over his notes, that he sort of cherry-picked the data that he had, which didn't really support the fact that his experiment was supposedly showed that Einstein was right and Newton was wrong. And this led to Einstein's special and general relativity becoming almost a religion, where you're a heretic. And so that's not honest. Calculations. He was more of a propagandist.
Yeah, so Sankar, I didn't notice anything like that in your material, suggesting that perhaps GRT and maybe later SRT, actually the other way around, was accepted after the 1919 eclipse expedition by Eddington that seemed to make Einstein a hero overnight. And maybe the accuracy of the data there about the bending of the starlight, because that came out of your equation also that I referred to earlier. You've no comment on that. Do you probably do you agree with what Danny has just said?
Do you agree? Eddington experiment.
No, yes. I believe gravitational bending of light rays reaching the sun can be explained from classical physics. I have shown this in my talk, that the gauging bending angle of the star rays when it comes by the side of the sun, the angle can be easily deduced from classical physics. I have reduced that GM by c square r square, the quantity. This is due to the fact that the light is subject to the gravitation of the sun. There is no need of space-time curvature. This can be easily explained that light is subject to gravitation, and that can be Therefore, Eddington's recording is correct. Recording the measurement is correct. That I do not dispute. But I dispute on the space-time curvature. I believe that the sun is attacking the ray of beam, and for this attraction, the beam is being deflected toward the sun, and that I even calculated. That can be done from Maxwell electrodynamics.
And I seem to have noticed the same value you gave from your equations as the Einsteinian one or the claimed one from the Eddington experiment, because basically you seem to get the same differential equation. But for my part, I'm even more dissident in this. If you calculate it using Newtonian physics, you get half the value. It's something like 0.76. Now, I think that's probably correct, and the double value is incorrect. I don't know if either of you gentlemen have any views about that. So, Denny, what I'm saying is, if you work this out as an orbit of virtual particles, you'll get that the deflection skimming the limb of say the sun, I think it should be 0.76 seconds of arc, whereas Einstein's value is twice that. And I think Sankar's value is twice as well. It concurs with the GRT value.
Well, I think that
I don't
the
believe in
problem
time
starts
dilation.
with special relativity.
Go ahead, Denny. You're both speaking at once.
I
Yes,
think
Denny,
the
what were you
problem
saying?
starts with special relativity, and then, as you pointed out, you can't assume that the velocity is constant in all frames and everything. That's ridiculous. You have to use instead of the Lorentz transform, you have to use hydrodynamics as a model for how to compute the velocity of light. And you pointed that out in your book, that something that ends in no analogy. It's not a book, it's a paper. What was the name of your paper that ended in no analogy?
Something like electromagnetic radiation, an anomaly or analogy, something like that. Yeah, I think they gave a bit of a fancier. They said anomaly, no analogy, something like that. Yeah. You're right. So it's analogous to hydrodynamic motion of waves, and why should it be singular with a speed limit? But you're right that the GRT business sort of elevated Einstein to a superstar. And I don't know what you think of this, Sankar, but it appears to be backwards. Special relativity after 1905 was looked at with, I think, some suspicion. It seemed to be quite ridiculous. And it was only after 1919 eclipse expedition and all the publicity about Einstein displacing Newton that maybe SRT became part of the mainstream. Do you agree with that? Yeah. It's a bit hard to have these longer discussions, so we might have to leave it there, Denny. But thank you very much for raising those points.
All right.
About Morton Spears and about the 1919 expedition and Eddington and all the rest. And yeah. So if we can leave it there for the moment, Denny, I'll move on because I think.
Right,
thank you very much.
Okay.
Thank you very much. Keep an eye on everybody as well. Now, I'll tell you, I shall. I promised the gentleman in Venezuela whom I couldn't hear that I'd bring him back, and he's gone now, so I'm not able to do that. Okay. Now, are there any other hands raising before I bring people in? Because I'd like to hear what a couple of you say. There's Cornelis. Now, Cornelis, What's your brief response to what Sankar has been doing, and have you any specific questions you'd like to put to him?
Okay, I just had to try to unmute. Can you hear me okay, right?
I can hear you perfectly, yes, Cornelis.
Okay.
There's some background, but I don't think it's you.
Let me try changing my headset. Does that help any?
I don't think it's you the problem. I think when I speak, I'm getting a terrible echo. I think it's through Sankar's system, actually. And I'm speaking quite loudly. So it's all right. Don't worry, we can hear you well.
Well, let's see if I can find the microphone for the. I think I might be picking up my microphone from my headset and from my computer. But anyway, I think you tried a couple of times to slow Sankar down, and I would appreciate it if been a little bit slower. Not only it would have been a clearer speaking, but it would have been easier for me to keep up with the reading because I'm a slow reader. So, but I do appreciate that he had the words on the screen.
Well, thank you very much. Yeah.
A lot of it does seem to be, it doesn't really contradict Einstein. It just seems to be like you say, a different way of approaching getting the same results. But there are some things that are like is against curved space time, and there are some things that I don't quite understand how that could happen. For instance, the light going past the sun. Einstein, has a number that's twice as large, but you also have a situation that as the light ray enters the sun's gravitational field, it has changes the refractive index, so it slows down. Just like when it enters the Earth, it slows down. So then that's fine. But a particle would speed up. Okay. Under the gravitational force of the sun. And the other thing is that once it does slow down on exiting the sun's atmosphere, it speeds up all on its own. And as far as I know, I'm not sure of any particles that can self-motivate themselves to accelerate. And the same is true of light leaving the surface of the Earth. It accelerates as it leaves the surface of the Earth, which is contrary to what particles would do. They would be slowed down by the gravitational pull. So I don't quite see how that works out versus particles versus wave characteristics.
And by the way, Cornelis, the points you just raised are interesting for Sankar to address. But I was also thinking of the points raised. What was it? God, what's the gentleman who worked for NASA and died? German-American guy. I've just forgotten. He was talking about the refractive index as well in the limb of the sun, affecting deflection of the ray. And if you go far enough, there's no deflection. So Sankar, I don't know if you got that. We've raised a number of points. Cornelis has raised a number of points about kinematic effects and acceleration and so on. And I've raised a point about I've just forgotten his name. He talked about the variation in the refractive index in the corona of the sun when it's traversed by a ray of light, and he actually explains away the deflection in those terms. So I don't know if you got that, Sankar. Would you like to say anything about Denny's points or my additional one?
Refractive index matter for a sun.
Yeah, Dr. Dowdy. Sorry,
Yes,
Dr. Dowdy,
yes.
thank you.
Yes. When light comes by the side of the sun, there is a big atmosphere, there is a dense atmosphere around the sun. And therefore, when it enters that atmosphere, its velocity is diminished. And due to this diminishing of velocity, it is attacked by the sun's gravitational field and it bends. This is the mechanics of the bending of light rays grazing the surface of the sun.
refractive index.
Yes, refractive index has some effect on the propagation of the light around the sun's atmosphere. Refractive index has some effect. That is also some effect. Both the effects, gravitational field effect and refractive index effect, both effects are contributed to the angle of glazing of the sun and glazing of the starlight when the glazing the side of the sun. I believe that I will not believe it is fact that light is attracted both by sun and it is also coming to a dense atmosphere of the sun's atmosphere, and therefore the velocity is also retarding in that atmosphere too.
That still doesn't talk to, he just said that it speeds up as it goes into the sun, and light reduces in speed as it enters the gravitational field. That's what it does on Earth anyway too. So that's kind of contrary to what we see. And plus, the fact that it's speeding up as it's exiting the gravitational field is contrary, and the curve continues. It comes in and it curves this way, but as it exits, it continues to curve that direction. It doesn't come this way and then curve outwards as it passes the apex. So if it were a particle and it was accelerating, it would curve outwards. But since it's continuing to curve with the sun around the sun instead. Do it.
So
But even a satellite going past the sun's, even a satellite going past the sun accelerates as it goes towards around the sun.
So you think there's a bit of a contradiction there, Cornelis?
Yeah, I believe so. That's why I'm saying there's a difference between particles and waves there. But that's one of the points I was looking at. It's not all, but you're limited times. So.
You sort of favor a wave type theory, do you, Sankar? I'm not quite clear on that.
Wave type theory. Do you support wave type theory?
Wave. Light is a wave. Obviously light is a wave. Light propagation is a wave propagation.
Okay, but it has mass then. He also believes it has mass. Okay.
You believe it has mass or perhaps rest mass?
Yeah.
Light is subject to gravitation. Charges are subject to gravitation. Electromagnetic fields are subject to gravitation. If you consider that electromagnetic waves, electromagnetic fields, and light is subject to gravitation, then I believe that Albert Einstein's theory of relativity, gravitation physics is not necessary. Light is subject to gravitation, charges is subject to gravitation. When a body moves around the sun, its charges also subject to gravity of the sun. And for this reason of Mercury, when a gyroscope moves around the earth, then it has charges, and the charges contribute to the gravitation. And for this, there is precision of the gyroscope. And now the gravitational wave, it is a fraud, it is a fake experiment. They have considered the experiment that they have assumed that the velocity of light in the compressed space and the contracted space the same. This cannot be. They have calculation emerged that when the light comes, when a gravitational wave comes, the space is contracting and space is expanding. But how there will be the velocity same c inside that space? Therefore, the calculation of gravitational wave they have done in the LIGO Virgo, their calculation is wrong, and by this wrong calculation they have tried to prove that there is the existence of gravitational wave.
Yeah, that's your fundamental beef with the LIGO Virgo experiment.
LIGO and Virgo. Virgo claim that they have proved gravitational wave. It is a fake experiment. Because why fake experiment? Because when gravitational wave comes the species contacting and species compressing and species rarefying. Now, in these two phases, the velocity of light could not be the same, but they have calculated that in the contacted phase, velocity of the gravitation is c, and the rarefied space, the velocity of the gravitation is c. How could it be correct? No, that cannot be correct. It is wrong calculation.
So, by the way, Kev Con has said, just a comment on the Dowdy, he says he was factually wrong about how far from the sun the light bending is detected. But he also says gravitational lensing around galaxies proves him wrong and Einstein right. Well, I think our speaker would say gravitational lensing just proves the phenomenon, not necessarily Einstein's conception of it. I don't know if you'd like to comment on that. But so, Cornelis, anything else before we move on?
Well, to that respect, though, yes, I was thinking about the nonlinear frame and curvature, because he's also saying that as charges accelerate and speed up, they deform, if I understand correctly. And also the situation of if there's frame dragging of the Earth, that frame dragging would be nonlinear as you go higher and higher in the atmosphere. So to me, that frame is being dragged at a different velocity, which indicates, to me, is a curvature of space-time. I mean, that's basically the electromagnetic field that things are made of, and mass is, and the mass is rotating, and all of what that mass and electromagnetic field is combined of is rotating with the Earth. So all that field is essentially the space-time itself, being warped and shaped into different shapes. And so the magnetic field and the particle, electromagnetic waves as well, are carried with the other electromagnetic waves. It is like a Fresnel dragging effect. Everything that's rotating of the Earth is waves that emanating from particles. So therefore, as light comes through that as a wave, the Fresnel drag would drag those. So I see that. I don't see that as any different than explaining Einstein's curvature of space-time. Anyway,
it's an interesting way of trying to integrate those ideas, because you're sort of looking at a frame dragging maybe maximum at the surface of the Earth, diminishing, and therefore you're getting an effective type of quasi curvature, which is an interesting way of looking at it. Have you any idea? Comment on that, Sankar? Sankar? No. Okay. Okay. Thanks very much, Cornelis, for those ideas. I think we're going to have to deliberate a little more on them. We'll move on because we're running out of time. Thanks very much, Cornelis. Now, I think we're going to have to wrap up now, unless Vladimir or James wants to come in very, very briefly. I haven't brought them in, but I know that both of those gentlemen, I'm sure, would like to ask quite a number of questions on this, which would absorb more time than we have. But if it's possible, if you'd like to say something very quickly about whether you think there's merit in what Sankar says or not. Well, if not, we'll leave it and we'll have our own private chat maybe tomorrow at Harry's session or something. So thanks very much for that. Okay, so I think we leave it at that for today, Sankar. What I'll do, it's the normal situation that I adopt, is if you give me the floor, permit me to speak myself for a couple of minutes. I'll summarize that. But before doing that, I wish to give you the floor again. You could have 5 minutes if you wish, maybe to summarize your talk, to summarize in the light of anything that's arisen in regard to our questions, anything that perhaps you haven't dealt with or you'd like to deal with in the future, or maybe any further references you can give to people. And then after you've done that, I'll come back and officially close the meeting. So I'm going to give you 5 more minutes to summarize and say anything else you want to say.
Cornelis.
Hmm?
Cornelis.
Hmm.
If I am not wrong, Cornelis said that the wave may carry the particle. Is it?
No, my field of study, my field of study does not cover this. My point is separate. I am trying to say that gravitational effects, which are explained by Albert Einstein, can be easily explained from Newton and Maxwell. But I do not, what is Cornelia saying, I don't know well in that line. I am not very conversant in that line. I am only speaking that electromagnetic fields are subject to gravitation, and it will explain all piling phenomena electrodynamics. And secondly, I say that electric charges are subject to gravitation. It will explain the advance of period on Mercury, bending of light rays, Shapiro time delay, and it will fully explain the NASA experiment of precision of gyroscopes, and fourth, it will discard the gravitational wave. I do not, gravitational wave has not been proved. My point is this. My point is this: all gravitational effect can be explained from Newton and Maxwell. All planets contain charges, and charges are subject to gravitation, and therefore the planets precedures, and therefore gyroscope precedures, and therefore there is gravitational wave. Albert Einstein has done Albert Einstein view that space-time curvature, it is all those concepts are fantastic concepts, all those concepts, imaginary concepts, those are the rational concepts. We are trying to explain the electrodynamics and gravitation from very rational standpoint. Cornelius' view, I cannot say.
Actually, I cannot follow what Cornelis said.
Okay, well, perhaps
Carrying
perhaps I'll come in and officially close the meeting, because I wish to say a few words about the presentation and about our response to it and so on and so forth. I'd like to thank, on behalf of the CNPS, Sankar so much for having given us the talk today. And I'd like to thank his colleague Saman for having helped. I think he did help to smooth over a few of the incomprehensions between us, which frankly have arisen. But I think many of the participants here through the YouTube today, I think there was a problem with the Facebook, unfortunately, and also directly into our green room, who haven't been familiar perhaps with much of the material that Sankar has produced, would do well to research it further. I'm sure they won't be disappointed. I've referred to the book there, and there are also these papers, particularly in the Bulgarian Journal of Physics, these two papers. But if anybody's in difficulty sourcing some of the material, let me know and I'll assist. I've spent a certain amount of time. I'm going to spend more time actually now after these two lectures to have a look at this material. I'm actually very much impressed with the amount of analysis that Sankar has involved himself in this. I haven't been exposed to the material before, Sankar approached me some months ago about giving lectures. And I'm actually frankly impressed, because it appears to me, I don't know very much about Sankar, it appears to me that he's not a professional physicist. I think his career was probably in the financial areas and so on. And he spent many, many years looking into it in details. I think he refers to the late Michael C. Duffy, who was in charge some years ago of organizing these lectures on special relativity and so on, questioning fundamentals in London. I think he's deceased now, but he helped Sankar a lot. And there are a couple of other people in his own country who've helped him a lot, and he's given credit to those. But I'm extremely impressed how he's gone into the details. Whether you agree with him or not, he's gone into great details with regard to Newtonian physics and Maxwellian electrodynamics. He's got all the equations there, Poisson's equation and D'Alembert's equation, and it's quite theoretical. I think one of the comments here was that it's so complicated that there must be a lot in it. I can't understand it. The maths is beyond me. Somebody said that. So he's gone into great details, and he has these, what did he call it, virtual values or something. So he's getting like an effective type of transformation because he's transforming from the x coordinate to the t coordinate, and you get the gamma 1 minus v squared over c squared coming in, and so on. So he's showing how the effective Lorentz transformations could arise by looking at purely classical means, which is very similar to some of the things I've done. I've looked at, as Denny said earlier on, the hydrodynamic analogy, and just applying the total derivatives, and you get this sort of form. So I'm extremely impressed, and I'm not just saying that as host. I really think it's worth your while going into in much greater detail. I'd like to thank you all for participating. I'd like to thank you for your questions. I know we in the CNPS will be discussing this among ourselves, actually privately, and with Sankar's permission, we might even come back to him with some questions. And I do invite you all to do that as well. If you're dissatisfied with any of these points or you have any questions, just pop a note in, and it can be done through us. We can forward them to Sankar, and we'd be delighted to act as a conduit between people. It's also very much invited for people to contact Sankar individually, because if all the communication is going through me, well, then you have another possibility of introducing inaccuracies. I might misunderstand the question or maybe the answer. So either way would be interesting. And I know some of us will be discussing this between ourselves, maybe at some of our informal presentations. So I'm also quite happy. I'm always happy to have some blunt talking, provided it's polite, and it's always been polite. People nowadays, they're blunt, but they're rude. Sankar talks about all this modern physics as being phantom physics. And I think that's a blunt but very polite way of expressing the views of many of us on the modern ideas, with all the paradoxes and, it's against common sense, but you have to believe it because it meets experimental criteria. He just dismisses this as phantom physics. I think it's actually a very good word, phantom, imagination, that's all. So I'm so delighted we've had him, and he's I think he's gone now, actually. But I'm speaking in his absence, but it'll all be recorded. I'm going to stop the stream now. I'm delighted that we had Sankar for the two presentations, and I'm glad that most of you have borne with me any difficulties that we had in comprehension or language, or even difficulties with the audio and so on. So I think we managed fairly well. I was in some apprehension about today, but I'm very much glad that Sankar had his colleague Saman to help him today. So without further ado, I'm going to wish you all a very good day. Thank you very much for participating. And thank you again. No, Sankar is not gone. He's still here. Thank you very much again to Sankar for having taken considerable trouble to have his lecture totally out in script, as well as reading it. So that did help some people. They have said that they could read it. That did help somewhat. So good day, and thank you again for being with us today. Good day.